Video is for Math 60, and this is for the sample midterm. So your midterm will be very similar to the midterm that I've posted along with this video. It will have the same number of questions, it will have the same kind of questions, but they'll be different questions. I'll try to point out good places where you can make a note to yourself, because you're allowed to bring a 3x5 note card with you to the test. You can put anything you'd like on the card. For example, in a few minutes I'm going to be going through some percentage problems, so if you want to write down, sort of that is over of equals percent over 100 on your note card, then that's something you can do to help yourself remember that. All right. Well, let's go ahead and get started. Let's see here. Problem 1 is a proportion problem. It says a 40-acre field yields 600 bushels of wheat. At the same rate, how many bushels will a 75-acre field yield? Okay, so we can set up a proportion. We've got 40 acres, and that's going to produce 600 bushels of wheat. And then a 75-acre field, remember we want to line the 75 up with the 40 acres, and then the X bushels will line up with the 600 bushels. And then again, to solve this, we're going to cross multiply. And you can do this, algebraically by writing 40x equals whatever this is going to be, and then dividing on both sides by 40. Or you can just multiply these two and divide by 40, whatever you prefer. Let's see here. So 75 times 600, and then divide by 40 is 1,125 bushels. Okay. Problem 2 is also a proportion problem. 3/8 of an inch represents 120 miles on a map. How many miles are represented by 4.75 inches? Okay, so let's set up a proportion. 3/8 inches is 120 miles. And then we've got 4.75 inches, and the question is, how many miles is that? Okay, so again, we're going to do the same process for solving. 120 times 4.75, and then we're going to have to divide by 3/8. So you sometimes run into fractions, and you should all have calculators with you. And so understanding how to work with fractions on your calculator is a good idea. So let's see, 120 times 4.75, and then we're going to divide by 3/8, and so x should be 1,520 miles. Okay. And that seems reasonable. This is almost 5 inches. This is less than half an inch, and so this is going to be more than 10 times bigger. So let's see here. Where are we now? Problem 3. Okay, so this is where we get into the percentage problems. And again, you've got your choice here. You can set them up as is over of equals percent over 100. Or you can say, the percent as a decimal times of equals is. That's another way that you can set this up. But if you do it this way, you have to use the percent as a decimal. You have to turn it into a decimal first. Okay. So, problem 3, 48 is, okay, so that 48 is 75% of what number? So the of is what number, and that's where our x goes. So we go 48 times 100 and divide by 75. and we get 64. Okay? And that seems reasonable. There's a variety of ways that you can check this out. You can divide each of these and see if they give you the same decimal. If the top number is smaller, it should be smaller in both of them, and so on. All right, problem 4. What is 18% of 620? All right, well, let's see. What is, so that means is going to be our unknown. 18%, so the 18 goes up here, and then of 620 goes down there. Okay, so then we'll go 620 times 18, and then divide by 100, and so x is going to be 111.6. Okay. Let's see here. Problem 5. What percent of 170, whoops, 170, is 25? Okay, so the is goes on top, the of goes on the bottom, and the percent in this case is what we're looking for. So we do 25 times 100 and divide by 170. And let's see now. In this one, I think, now if I don't tell you where to round it, I have to accept any reasonable answer. And here, 14.7% is a reasonable answer. But if you rounded it to 15%, I wouldn't take points off because I didn't specify where to round it. Okay. Frequently, if we get an answer that's got a long non-repeating decimal after it, I'll say round to the nearest 1/10 of a percent or something. All right. Let's see here. That was problem 5. Problem 6. What is 40% of 75? So, problem 6. What is 40% of 75? So the 75 is the of, the 40 is the percent, and the is what we're trying to find. So we do 75 times 40, divide that by 100, x is 30. So 30 is 40% of 75. Now if you want to use this method, like on this question, then you would say 0.40 times 75, and then that would just be your answer, okay? And that would turn out to be 30. And either one of those methods works. Let's see here. All right. Problem 7. 48 is, all right, so that means 48 is 75%. Let's see here. Yeah, I just did this one. This is actually problem 1 again. So I'll fix that before I post the test. I thought it sounded familiar. But all right, so let's do problem 8. Problem 8. 16 is, there we go, 16 is what percent, so that's where the x is going to go, is for the percentage, of 128. So the 128 is our of. All right, let's see here. So what do we do? 16 times 100 divided by 128, and that's 12.5%. Here there's no reason to round, so please don't round. Okay? It's when you see that long string of non-repeating digits after a decimal point, that's when you want to round. All right? Okay, let's see here. So that's it for those kinds of problems. Now starting with problem 9, we've got these percentage word problems. Okay, so this is where you have to kind of figure out which of these correspond to which of the numbers in the problem. And so let's talk about it. And in that situation, it's useful to think of this as the part versus the whole. Okay? The part typically corresponds to is, and the whole typically corresponds to of. Alright, so let's see here. Jenny wants to leave a 16% tip for a dinner bill of $74.25. How much should she leave as a tip? Well, the percent we know is 16. So let's see, problem 9. We know the percent is 16. Now the question is, what's the is and what's the of? So the question you should ask yourself, the bill itself in a tipping situation, is that the part or is that the whole? Well, that should be the whole, right? Because the tip that you're going to leave is a part of the entire bill. So the bill, $74.25, is the whole, which corresponds to of, and we're looking for the tip, which is the part, which corresponds to is. All right. So let's see here. We do $74.25 times 16 divided by 100, $11.88. And although you might just leave $12 in a restaurant, I would ask for the answer of $11.88 because we don't have to count out the change on the test. Okay? All right, so that's problem 9. Problem 10. 1 serving of trail mix contains 67 grams of carbohydrates. This is 22% of the recommended daily amount. What is the total recommended daily amount for carbohydrates? All right, well again, we've got the percentage, that's 22%. Now the question is this 67 grams of carbohydrates, is that the part or is that the whole? Well, it's the part because it's a part of the recommended daily amount. And notice the last sentence asks, what is the total recommended daily amount? That's an indication that that's the whole. That's what we're looking for. And the 67 that we're talking about is just a part of that. All right, so now that we've got it set up, we do 67 times 100 and divide that by 22. And here's another place where we would want to round. Although this is a repeating decimal, 304.54 repeating. So we actually don't have to round this one. Just put a bar over the repeating part. Okay, let's see here. Problem 11. Oh, let me make some space here to do problem 11 because this is a little bit tricky. And this is another thing that you might want to put on your note card, is how to do these discount problems. Okay? So in problem 11, the flat screen TV is on sale for $550. I'm going to write, instead of saying on sale, I'm going to write sale price. Because that means it's already been discounted, right? The actual price used to be higher. The TV has been discounted 20% for the sale. Discounted 20%. What that means is that there was some price, then we subtracted 20% of that price, and that's what this represents. The new price is 0.80. Another way to think about this is if you take 100 minus the discount, then that's 80%. Okay? So what this is saying is 550 is 80% of what number or what price. Okay? So that's what's going on here, is that you want to take 100 minus the discount, and then this is this percent of what original price. Okay? So we can go ahead and set this up. Let's see. 550 is 80% of what number? And so we'll take that 550 times 100 and divide it by 80, and X should be $687.50. All right. Let's see here. I think there's just one more of these percentage problems. So let's see here. Let me add something up to the top, which was that which I just erased, where you might want to do, discount problems, 100 minus the discount percentage equals the new percentage. And then you can just use this, okay? Where the discounted price is, and the price that you're looking for will be up. All right. Number 12. One more percentage problem. In a recent poll, 3,500 people were asked a particular question. If 1,925 people answered yes, what percent of the total does this represent? All right, so what percent says that we're looking for the percent? Now again, the question is the 3,500 the part or the whole, and is the 1,925 the part or the whole? So, sometimes you can rely or you can assume that the smaller number will be the part and the bigger number will be the whole. But that's not always the case, right? If this percentage is more than 100, the part will actually be larger. So that's something to be concerned about, be aware of, okay? But look at the information. The total number of people that they polled is 3,500. That has to be the whole then. So yeah, in this situation, the small one is the part, the big one is the whole, and we can just go ahead and solve for the percentage. All right, so 1,925 times 100 divided by 3,500, X is 55%. There we go. Okay. Problem 13. 64 ounces of juice costs $3.84. How much does 1 ounce cost? Okay. Well, to get from here to here, you have to divide by 64, so do the same thing over here. Divide by 64, and let's see what we get. $3.84 divided by 64, 6 cents per ounce. Okay. Problem 14. Board's starting to get a little bit dirty here. All right. Problem 14. What do we have? This is kind of a tricky problem. Jane can run 100 yards in 9.6 seconds. Paula can run 100 meters in 10.8 seconds. Who's running faster? Well, Jane took less time, but the reality is, you may or may not realize this, 100 yards is shorter than 100 meters. So we can't necessarily say that she was going faster because she covered a shorter distance, even though she ran in a faster time. So what we've got to do here is essentially two things. We can convert some of these yards to meters and so forth, or we can convert these into speeds. Think of this as yards per second, or we could do this in meters per second, or we could put them both into feet per second. Okay? I'll probably do this in two different ways, because right now I'm really leaning towards just making this all in feet per second, because I think we've got a good conversion here for converting these meters, right? Because I think the conversion, and all the conversions that you need will be on the test paper. If there's something on the test paper that you think you need that you don't see, be sure to let me know. So here's the conversion that we need, which is that 1 meter is 3.28 feet, and over here, 1 yard is just 3 feet. So this is going to be 300 feet in 9.6 seconds. So we can go ahead and divide that. 300 divided by 9.6. And so that's going to be 31.25 feet per second. Right? Now over here, I'll go ahead and make a proportion. 1 meter is 3.28 feet. So 100 meters would be X feet. Okay, and it's going to be 328, right? This times 100 divided by 1, so that'll be 328 feet in 10.8 seconds. So we go 328 divided by 10.8, and that's 30.37 feet per second. Yeah, it turns out Jane was running faster, okay, because she's running 31 feet per second, whereas Paula was only running about 30 feet per second. All right, so that's one way to approach this. Let's see, what else could we do? I don't know. I think that's the best way to go about doing it. I don't want to get tangled up in solving this in some other way that isn't as straightforward. So I think I'm just going to leave this alone the way that it is. Okay. All right. Let's move on. Okay, now we get to these problems with the positives and negatives. And again, you can use your calculator on these, so just be sure that you understand how to do these on the calculator. Problem 15, -3 plus -9 is going to be -12. Okay? I often think about this in terms of a number line where plus takes you in this direction, minus takes you in this direction. So in this one, you're starting out at -3. And again, remember that when you have double signs, it's usually, I find it really helpful to turn them into just a single sign. So, different signs make negative, same signs make positive. Okay? Let's see here. Right, so we're starting at -3. This turns into just -9. So that takes you this way 9 places, puts you out at -12. Oh. Put that down here. There we go. All right, problem 16. 7 minus 18. So here you are out at +7. The -18 is going to take you 18 places in this direction. Takes you 7 places to get back to 0. And then you've got to go another 11 places after that to make 18 total. And so there you are. That'll put you out at negative 11. Problem 17. 5 minus negative 17. So here, and this is something that you might want to put on your note card, right? Is how to handle positives and negatives when they come together like that. Okay? Let's see here. I don't see any problems on here like this, but it's important to understand this and this will make a positive. But if you had something like, see right here, negative 3 minus 9, those aren't right next to each other. This negative is affecting the 3, this negative is affecting the 9. They're not affecting each other. This negative affects this negative by turning it positive. Okay? So this is 5 plus 17. If you start at the 5, you go 17 places out this way. That'll put you out at positive 22. All right, problem 18. Negative 6 minus negative 12. Very similar to problem 17 because you've got the negative there. That'll make this positive. Negative 6 plus 12, that's the same as 12 minus 6. You're going to end up with a positive 6 as your answer. Let's see, let me make some space here. And we're on problem 19. So these are the multiplication and division problems. Negative 8 times negative 4. So now here's the thing. When you're subtracting, I just a minute ago gave you this example, negative 3 minus 9. That's subtraction, okay? This negative does not affect this negative. You start at negative 3. This takes you 9 places further out into the negative numbers. This is multiplication. When you multiply a negative times a negative, they do affect each other, and this will give you a positive 32. You don't have to put the plus sign, all right? You can write it as plus 32, or you can just write 32, but it is a positive number, okay? And so that's just a difference between adding and subtracting versus multiplying and dividing. Okay, problem 20. 16 times negative 3 is just going to be negative 48, right? Positive times a negative will give you a negative. 21 is positive 21 over negative 7. And this is true for division as well. If you divide different signs, you get negatives. If you divide the same signs, you get positives. So this is going to be negative 3. Problem 22. Negative 56 over negative 4 is going to give you positive, I believe that's 14. Or just plain old 14. Okay. All right, so that's the positive and negative calculation section. We'll do a little bit more with that in a minute, but not with just straight calculation. Let's see here. I think I'll move that up here along with the other suggested things for your note card. Drink of water. Okay. Problem 23, express 54 as the product of prime factors. So 23. Express 54 is the product of prime factors. So that means we want to make a factor tree, okay? Start out anything, you can start out however you like. If you recognize 54 as 6 times 9, great, you can make it 6 times 9. If you don't recognize 54 as 6 times 9, you can at least perhaps recognize it as an even number. And then do 54 divided by 2, and that'll give you 27. Okay? Either one of those is correct, but you have to keep going until you have only prime numbers. Okay? At this stage, the 2 is prime, so we'll put a circle around it. The 27 is 3 times 9, and the 9 is 3 times 3. So there's all of our prime numbers, the 2 times 3 times 3 times 3. That's one way to do it. Do the same thing over here. Neither one of these is prime. The 6 is 2 times 3. The 9 is 3 times 3. Here's all of our prime factors, 2 times 3 times 3 times 3, and there we go. All right. The other way to do a factor tree is to do the 54, divide it by 2, divide it by 3, and divide by 3 again. And then here's all of your prime factors. Okay. Let's see here. All right, problem 24 and 25, well, 24, 25, 26, and 27, we've got all these order of operations. So this is maybe something else for your note card, right? You want to do addition and subtraction last, multiplication and division before that, and exponents and roots happen first, right? Work inside the parentheses and then go in this order. Right? Exponents and roots first, then multiplication and division next, and then save the adding and subtracting for the last. So, problem 24. 2 minus 9 squared plus 5 times negative 6. Okay, so the first thing we want to do, work inside the parentheses. Get inside the parentheses, just have a single number. See how you just have a single 5 inside these parentheses? That means we don't have to do anything more there. Same thing here. But over here, we've got 2 minus 9. That's negative 7. Okay, now we've just got a single number in there. Now, let's see. We should calculate the exponent first. Negative 7 squared is positive 49. A lot of people get thrown off by this. I see this all the time. It's one of the most common mistakes people make with their calculators. They type in this, and the calculator reads it as negative 7 squared, or negative 7 times 7, and then the calculator says, oh, that's negative 49. But that's not what this is saying. That is saying we want negative 7 times itself. Negative 7 squared is negative 7 times negative 7, negative times negative, positive 49. Okay? One way to avoid this is to know, if you square a positive number, you get a positive number. If you square a negative number, you still get a positive number. Okay? So if you're squaring something, in most cases, you're going to get a positive number, and that should be an indication to watch out. Don't make this mistake. All right, so there's 49. 5 times negative 6, negative 30. You can have an intermediate step in there where you say 49 plus negative 30. That's fine too. Okay, I'm just saving a little bit of time there. And then just do 49 minus 30, and that should give us 19. Okay, let's see here. Problem 25. Negative 2 to the third power, not equals. There's no equal signs in these problems. There we go. Minus 5 times 1 minus 8. Okay. So let's see here. This parentheses just has a single number inside of it. It's all ready to go. This one we should calculate there. Minus 5. 1 minus 8 is negative 7. And then we want to do negative 5 times negative 7. That'll give us positive 35. Now, if you just want to do, if you want to think of this as 5 times negative 7, you'll have to keep that subtraction sign. Okay? And get minus negative 35, right? Because that minus sign stays there. There's your negative 35, and then you get a minus negative 35. I just look at it as negative 5 times negative 7 is positive 35. Okay, however you go about doing that, this will be positive 35. Now, this is similar to what we were talking about over here, but see, this exponent is to the third. So when you do negative 2 to the third power, that means you want to take negative 2 times itself 3 times. Negative 2 times negative 2 is positive 4. But then when you multiply it by negative 2 again, your answer is going to be negative. Okay? And so this will be negative 8 plus 35. And so that looks like it should be 27. Okay. Let's see what else we've got to look at here. The trickier order of operations problems where you have a numerator and a denominator to worry about. So, problem 26. 8 times negative 3 plus 10 minus 22. 4 squared plus 2 times 3 minus 5. Okay. So my recommendation is when you've got a situation like this, follow this order of operations on the top separately, follow this order of operations on the bottom separately, get a single number on the top and on the bottom, and then worry about either reducing or simplifying or dividing, okay? Because don't forget, that's what the fraction bar means. The fraction bar means divided by. All right, so let's forget about the bottom for a minute. Up here, let's multiply these two together, because there's nothing to do inside parentheses. There's no exponents or roots, so the first thing we're going to do is multiply. So that'll be negative 24 plus 10 minus 22. Let's see, on the bottom here, I'll just leave it alone, and we'll finish off the top first, and then I'll worry about the bottom. You can kind of do it, you know, like I could work with this parentheses, I could square the 4. It's not going to mess things up, but I just want to reinforce the idea. Don't try to interact between the top and the bottom until you get just a single number on top and a single number on the bottom. All right, let's see here. So this is negative 24, negative 22, and positive 10. So what is that? That's going to be, looks like negative 36. Okay. All right. Then, just what I was talking about a minute ago, let's do the parentheses first. 3 minus 5 is negative 2. And then we'll have 4 squared. Well, actually, yeah, now that I've done the parentheses, let's go ahead and do that exponent. 4 squared is 16. All right. And that'll be 16 minus 4. Negative 36 on top. Positive 12 on the bottom. Now you can do negative 36 divided by 12. Negative 3. And there we go. Okay. Well, that's a good problem. I like that one. We got one more of these. Let's see what it looks like. Let's see. Problem 27. Negative 16 plus 7 times 6 on top. Negative 5 squared minus 12 on the bottom. Okay. All right. Well, let's see. On the top, we don't have any exponents or roots or parentheses really to worry about. And so we'll multiply 7 times 6 is 42. And then we'll do 42, or negative 16 plus 42. I think of it as 42 minus 16. It's the same thing. What is that going to give us? 26. Okay. Positive 26. See. Then down on the bottom, let's see. Let's just square that negative 5. Remember, if you're squaring a negative number, you should get a positive answer. Okay, positive 25. And then 25 minus 12 is 13. 26 divided by 13 gives you 2. Okay. So that's the order of operations section. Now we've just got 4 more problems to worry about. And these are the substitution problems and the combining like terms problems. So let's take a look at those. Problem 28. X is 3.5. Y is negative 1.8. And we want to calculate 8xy minus 15x. Okay? Well, let's substitute in our numbers. So this is 8 times 3.5 times negative 1.8 minus 15 times 3.5. Okay? Well, let's get out the calculator here. 8 times 3.5 times negative 1.8, negative 50.4. And then over here, 15 times 3.5, 52.5. So negative 50.4 minus 52.5, that's going to take you further out into the negative numbers, and we're going to end up at negative 102.9. Okay. Problem 29. X is negative 7. Y is equal to 2. And we're working with negative 4x plus 12xy. So, plug in our numbers. Negative 4 times negative 7 plus 12 times negative 7 times 2. Okay, let's see. This will be positive 28. And then this one, 12 times negative 7 times 2, that's going to be a negative answer. What is that going to be? 168? Yeah, negative 168. So this is positive, this is negative. 28 minus 168, that should be negative 140. Okay. 2 more to look at, which is good because my marker here is running low on ink. I have another one, but it's a different color, so I won't use it unless I really have to. Okay, problem 30. 2x minus 3 times 5x minus 4 minus 7x. Okay, so I like to think of this in terms of pieces, right? And they're separated by the addition and subtraction signs. We've got 3 pieces. This one and this one we don't really need to worry about or do anything with for right now. We want to follow the same order of operations. We can't do anything inside this parentheses, right? Because these are not like terms. If you had like terms inside the parentheses, then by all means put them together. But the main thing that we're going to see here is this distributing. We need to distribute that negative 3 into the parentheses. So this will be 2x and then minus 15x plus 12 and then minus 7x. Okay, so now we want to group all the like terms. Remember, the sign for each of these terms is directly in front of it, and if there's nothing there, then it's a plus. So let's look at all the x's. So we've got 2x minus 15x and minus 7x. Doesn't matter what order you do it in. This is going to be negative 22x plus 2 will take you back to negative 20x, right? 2 minus 15 is negative 13x. Minus 7 more x's, still negative 20x. And there's not a whole lot to do with the 12 because there's no like term to add it to, okay? So we're going to end up just with negative 20x plus 12. All right. Problem 31. Let's see what we've got here. This one, there's not a whole lot of work to do. It's just a matter of understanding how these problems work. Okay. So what's happening here is that here we can just take the parentheses off because there's nothing in front of them. Okay? We don't really have to do anything to what's inside the parentheses because there's nothing in front and there's also nothing right here. Sometimes textbooks like to put something back over here like a 3 or a 5 or something that you would have to distribute into the parentheses, and they just put it after it instead of before it just to try to confuse you. Okay? But this one doesn't have any of that. But here you do have this minus sign. Okay? And that minus sign is going to affect all of the pieces inside the parentheses. So this is going to be minus 3x squared minus 2x and positive 5. Now, once we've done that, we've got to match up our like terms. Okay? And we've got 3 different kinds here. We've got the x squareds, the x's, and the constant pieces. All right? And so, 7x squared minus 3x squared is 4x squared. Good. Negative 1x and negative 2x makes negative 3x. And then positive 4 and positive 5 makes positive 9. And there we go. Okay, so that's it for the sample midterm. Like I said, you'll see very similar questions on the test that we have next week. These are some suggestions that I've left up on the board that you might want to consider putting on your note card so that you have these things to refer to. You've got the order of operations, how to handle double signs, and then all of this stuff about regular percentages, and then this special thing for those discount problems. As always, if you have any questions, please let me know. I'll be happy to help you. Otherwise, I will see you next week. Thanks.